I wanted to show how to make custom symbols in SOLIDWORKS Electrical. It can be kind of confusing sometimes, and there's a lot of little pieces of information. And I feel like there's always a lot of questions about making symbols. And it's like a big building block in using this tool correctly. Okay, so there's going to be a few different ways to make custom symbols, and it really just depends on what you're going for and your workflow. But usually to make custom symbols, you're going to go to the library tab up here on the top. And I'm using SOLIDWORKS 2019 because that's what I have installed on this computer. It's going to be pretty much the same process for, SOLIDWORKS 2021, 2022, whatever the newest version is, and probably pretty similar to older versions. So it should be roughly the same. You're going to go to the library tab. This is where all of the managers are kind of kept. So anytime you want to create something new or modify something existing in one of your library databases, you're going to go to your library tab. Sometimes it's helpful to think about that. In this case, we want to create a custom symbol, so we want to go to the Symbols Manager. Okay, so the way this software works, and most of the interfaces work, is there's two tabs up here. There's the Classifications tab and the Filters tab. So classifications is categories of things. So however you want to classify or categorize your symbols, you can do that here. I tend to be more browsing through stuff than looking for something that I have specific. But that's just me. So I tend to look at this to kind of like browse through different categories when I'm looking for something. Notice up at the library tab at the top, there is a classifications manager if you want to add to this list. So you can add additional things to the classifications that you have here. I do not believe you can remove any of the existing classifications. I think you can just add your own and delete the custom ones that you've made. But that's not really the focus of this video. All right, so in this case, I'm just going to go show an example of how to create a three-phase motor symbol with a ground. It's pretty standard, normal symbol that some people might use. Obviously, not everyone's going to be using motor symbols, or maybe that's not the symbol that you need to make. So I'm going to try to be kind of general about it. But here we go. So down here, we have our motors classification. And this is going to show me all of my existing motors that are already in my library. And notice they're motor symbols. The way that SOLIDWORKS Electrical kind of breaks things down is there's symbols to represent a component, and then to pick a specific component from like a manufacturer or wherever you're going to buy it, there's manufacturer parts that you can apply to the component, and you have symbols that represent the component. So no matter what symbol I'm selecting here, it's just a graphical representation of a motor. It does not dictate which actual motor you're going to go to the store and buy. So it's just a graphical representation. One of the ways you could go about making a new symbol is you could copy an existing symbol and then modify that copied symbol. All you would do there is you would copy this symbol, and then you would right click and paste this symbol somewhere. I'm going to go for making one from scratch because that's typically the more challenging way to start. So I'm just pre-selecting this motor's classification. There are sub-classifications you could select. You can always move things around and reclassify things if you need to. I could select three-phase since I said it was going to be a three-phase motor with a ground. So I'm going to create a new symbol. I have pre-selected that classification right there. What you need to do is you need to make sure that the name of your symbol is unique in your database. So you want to give everything a unique name. It is required. You can see down here we have these life recap boxes that kind of give you a hint of what the software is kind of looking for. And you'll actually notice these throughout the software in a lot of places. But in this case, I'm clicking in this name box and it says the name of an object, and it cannot be empty and it must be unique. So I'm just going to call this thing example motor. Hopefully I don't have that already in here. Okay. So the description, it can be the exact same as the name of the symbol. In my case, is going to be extremely similar, but it does not have to be. So really whatever is going to help you find it easier is what you should give it as a description. The description does not have to be unique. This little plus button is if you want to add multiple languages to describe this thing, you can do that. I only speak English, so that's not something I can really do because I don't know how to type in other languages at this point. But if you wanted to, you could add other language description boxes, and then you could type in those descriptions there. All right, so the classification, notice it says motors 3-phase, and that's because I had pre-selected that classification before creating this symbol. If you either didn't think to pre-select it, or if you're changing your mind, you can always hit these ellipsis button, and then you can select whatever classification it is that you want. Okay. So I'm fine with motors 3-phase. The symbol type, there's a bunch of different symbol types. I should probably make a video to go through all of these different kinds. But in this case, most of the symbols that you saw in this motors classification down here are what are called multi-wire symbols. Multi-wire symbols go on schematic pages. And then they're just your standard insert symbol. They're usually what people are thinking about. There's a bunch of other examples for specific situations. A lot of these are kind of automation type symbols that come into play when you're creating like an automatic terminal drawing or stuff like that. There's connection labels, a bunch of different label types. You have black boxes. The one that we're making today is a multi-wire schematic symbol, and that typically is used on a schematic sheet when you're doing point-to-point wiring. So, all right, so the unit system here is usually the most difficult thing to change after you've created the symbol. So it's usually the thing that I'll recommend paying the most attention to when you're creating a symbol for the first time. Make sure you're using the unit system that you intend to be using. So most of my drawings are ANSI type drawings, so everything's done in inches. So I want to make sure that I'm using imperial unit system, so everything I'm drawing, I'm assuming it's being created in some form of inches. So I'm using imperial. It just gets kind of annoying to try to scale these things after the fact. And you can do it. It's just like my least favorite thing to do. All right, so you can customize company libraries, add your own custom user libraries, really whatever you want. I don't actually have a library I want to put this in, I guess. Maybe demonstration library, that might be good. But you can create your own custom libraries to organize your parts into to make it much easier to find later on. I'll just say, hey, this is a demonstration library. This manufacturer part category, I usually tend to leave it blank. What it is trying to do is it's saying like, hey, when you insert this symbol, do you want to automatically insert a specific manufacturer part in addition to the symbol? And sometimes that's maybe something you want to do. In my case, I'd like to have a somewhat generic looking symbol that, hey, in this example, I know I have a 3-phase motor with a ground, but I don't exactly know specifically who the manufacturer is and what part number I'm getting from it. And maybe in the future, I might be using a very similar manufacturer part, but I don't want to have to go and create a custom symbol each time. So typically I leave this blank because I don't want to have to make a motor symbol for each and every motor part number I might be using. So typically try to leave that blank, in my opinion. The systems area, you can't edit it, so don't worry about it. It just is telling it when this was created. In this characteristics area, the one I'll pay attention to most often is the mark root. So this is where when you insert the symbol, if I want my motor to be called M1, M2, M3, the mark root of that would be the letter M. You could type in entire strings if you want to. So if I want to say motor as my mark root, when I drop this thing in the page, it's going to say motor 1, motor 2, motor 3. I don't typically mess with the macros on these. It's a little bit more advanced than what I'm going for here. The standards is if you want to categorize something into a specific standard, you can do that. That's another way you can filter something if you want to. In my case, I'm just making an example motor symbol and I'm not following any standards, but you certainly could categorize that into something if you chose to. The cross-reference type, so cross-references typically will show some indication of that if that component is represented on another page besides the one that you're on. In this case, I'm not adding cross-references to it. That'll probably be another separate video by itself. But it would typically be to show where other representations of that same component exist in the same project, generally. Display connection points, I usually have this selected, and that's because in the project configuration, you can control whether you want to see the connection dots on the symbol or not. But if they're not selected on here, you have to go into the symbol and say that they can be seen before you can control it with the project configuration. So I usually always leave this on, and then if I need all connection dots to disappear, I can control that with the project configurations. And attributes orientation is if you rotate the symbol, how will those attributes behave? And I actually tend to forget which way I like it the most. I think I usually keep the box unchecked, but I reserve the right to change my mind about that at the end of this. I typically leave it unchecked, I think. All right, so I'm going to click OK. And what you'll see here is since I'm already in this 3-phase classifications, you can see it now, very barely see that it's selected currently. That is the new symbol that I've made. You can see that it's called example motor. If you go to the list mode up at the top, you can see the description of my symbol, the symbol name, as well as the classification it lives in. So I usually confirm that is the symbol that I think that it is, because if I start editing a different symbol, then I will confuse myself at the end of this. So always make sure that you're editing the symbol that you intend to be by confirming the name and the description of it. So you could double click, you could pre-select and click open, however you want to open the symbol to edit it. Okay, so this tends to be one of the most confusing parts of the custom symbol creation. Is when you create this custom symbol, you're just left with this blank page, and you don't really have a sense of space. I think in some of the newer versions, it actually shows the origin in the lower left-hand corner, but in the older versions, specifically in 2019, it tends to just live a little bit off page and you can't really see it. So I'm going to just hold my middle mouse wheel to scooch this over so I can see my origin. So I'm just panning that over. The other thing I'll tend to do when I'm creating symbols is I'll turn the grid on. It just gives me a sense of space, of like if I'm zooming in versus zooming out of something. So I will right click in this lower right hand area, these drawing perimeters area. And here you can turn on the grid. Typically when I design things, I have a 1/2 inch grid and usually I have things set generally at a 1/4 inch spacing, snap spacing. Um, you'll see here that the grid zone is, some kind of arbitrary size. I usually like to have the grid go into all quadrants of my drawing area. So I can just actually do a negative version of all of this. And then I'll have a nice little rectangle so I can see my grid zone no matter how I want to draw this. Hopefully that made some amount of sense. You can see in the background, I'm drawing with a white background and black um, lines and text on it, so sometimes it's a little harder to see the grid zone. I'm not sure how it'll come out in the recording, but you can very barely see little grid dots, which are helpful when drawing stuff. Okay, so when you're drawing a symbol, there's a few things that happen when you're actually editing the symbol. You're in the Edit Symbol tab up here at the top. So the tabs in SOLIDWORKS Electrical are context sensitive. So depending on what sheet you have active, it'll change your tabs at the top. So for example, if I opened a schematic sheet, you'll see I have the schematic tab active. If I go back to my motor symbol, you can see I have an edit symbol tab open. So context is really important in all the SOLIDWORKS products. I remember that was probably one of the more difficult things I had to train my very simple brain to get used to, is understand the context of what I was working in affected the tabs up at the top. So what you'll also notice too is the color of the tab. This one's light purple. That typically means that you're editing a symbol or a title block. Your yellow sheets here, typically schematic sheets. And you'll notice that each type of drawing has a different color on it. All right, so the Edit Symbol tab has most of the things that you need to do that are symbol specific. So inserting your attributes, adding circuits and connection points, moving your insertion point. So your insertion point is the red target that's on the page. I usually, when I'm making a new symbol, I leave it where it is. The insertion point means that when you drop the symbol on the page, where is your cursor going to be relative to the symbol? Most of the symbols that are already in the library have the insertion point on the first pin of the symbol. So that's usually like a good thing to stick with, is having the first pin have the insertion point on it so you know where you're dropping it is usually pretty handy. Okay, so that's the important things here. The Draw tab has all of like the different drawing tools you could use, so your lines and your rectangles and circles. And then the Modify tab has the ability to kind of like modifying existing geometry that's already on the page. So if you need to scale something, or, I'll come here to trim a lot of stuff, or doing like extensions of lines, it typically takes existing geometry and messes with it, which is nice. Oh, okay, to start, I'm going to go on to the Draw tab, and I'm just going to quickly draw something. I'm going to make a very simple motor symbol that has, is essentially a circle that has like 4 legs sticking off of it. Because again, I'm making a 3-phase motor with a ground. So I started my circle tool, and like all SOLIDWORKS products, well, all the ones I mostly use, you have some properties or command tab over here on the left-hand side. This usually kind of is giving you hints of what the tool expects you to be doing with it. With this one, it says enter the center of the circle, and then it'll ask you to select the radius of the circle. So if I click somewhere, and notice my cursor's snapping to specific points on the screen, and that's because I have my snaps on. You can see that it's dark gray and enabled, and that means it's snapping to every 1/4 inch on the page. Having the snaps is important because when you put this symbol on the page, you want it to look like not ridiculous with the other symbols that you're using. And it's very important to put the connection points on some snap grid so that when you draw wires up to it, the wires can connect, and then the database knows that those wires are connected. So snaps are super important, and it will make your life super challenging if you don't keep track of that, especially when you're putting your connection points on the page. Okay, so I'm going to draw a circle. So it's saying like, hey, click where the center of the circle is going to be, and then draw, the extent of where you want that circle to go to. That feels okay. I want to scoot that circle a little bit to the right, so I can go to the Modify tab. Notice I have the circle pre-selected at this point. So when I click the Move command up here in the upper left, it's not asking me what I want to move. It already knows that I wanted to move that circle I already had selected. So I'm going to roughly select in the middle because it's asking me where the base point of where I want to move it is. So I left clicked, and I'm just going to scoot this over to the right, just so I have a little bit more space from that insertion point. Okay, so at this point I have a sweet circle. Now I'm going to do is I'm going to draw 4 legs up to it for my 3 phases and a ground. All right, so I'm going to go to my line command, and then I'm going to start at that insertion point, and I'm just drawing it horizontally to the right. I don't really care where it ends right now because I'm going to go back through and trim all this stuff. So I'm just going to start the line command again. This is when I start keeping track of my snaps, because since I have my snap settings set to 1/4 inch apart, that means it can only click, my mouse can only possibly click every 1/4 inch. When I think about how this symbol is going to exist on the drawing or how I'm going to use it, a lot of my drawings, which are on B-sized, sometimes D-sized sheets, I tend to want my wires to be spaced 1/4 inch apart. If I only have the legs of my symbol, if I have the legs of my symbol set to 1/4 inch apart, then I'm going to be very easily able to draw 4 wires 1/4 inch apart up to my symbol. It takes no time at all. So what I'm going to do here is I drew a line up here at the top. I'm going to go down 1 snap setting and draw another horizontal line. It looks like my circle might be kind of big, but that's okay. I'm going to do it 2 more times. And I have a really hideous situation going on here. Okay, so for me, I have my first 3 phases and I have a ground. I can make this look different if I wanted to. I guess I could move this ground leg a little bit further down just to mix things up a bit. I don't know. Okay, so I have my 3 phases and I have a ground. My circle looks a little big, so I'm going to shrink him a little bit. And then I'm going to use my Move command on the Modify tab and scooch him up a little bit. If you see those symbols on my cursor, those are called O snaps. So the little like hourglass shaped one is the nearest O snap. And what that means is wherever it thinks that you're landing on an existing piece of geometry, it'll be like, oh, we could snap there. A lot of the time, I'll turn off my O snaps unless I specifically want to snap to existing geometry, because sometimes it's helpful, sometimes it's not helpful. I could probably get into a whole video on snaps versus O snaps. It does come in handy if you've used another drawing tool before, like AutoCAD or DraftSight or something like that. It's very similar commands and the very similar ideas of when you'd use it. But that should be another video I should make as well. Okay, so I'm moving the center of the circle just up and over a little bit because that's what I feel like. Yeah, that looks pretty good. Now what I want to do is trim those lines that are extending way too far. So to do that, I'm going to use my trim tool up here on the Modify tab. And I'm just going to select everything involved to be like, hey, all of you guys are going to be trimmed. And you can hit the green check mark to accept that and move to the next step, or you can use the right click button on your mouse to quickly accept that instead of having your mouse travel all the way up here. Okay, so I right clicked, and now it's saying like, hey, click the segments you want to remove. So I'm going to left click some things, and notice it's trimming those lines back to the nearest crossing piece of geometry. In this case, the stuff on the left-hand side over here looks awesome. The stuff on the right-hand side, I also want to disappear. So, and it's not letting me trim that back. So I'll just say, hey, we're good on the trimming. You can either hit the OK or the right click button or escape. It doesn't matter. And then what I'm going to do here is I'm going to select those 3 pieces of leg that I don't want. I'm using box selections, and I'm going to delete those because I don't want those pieces hanging out there. Okay, cool. The last thing I'm going to do is every good motor symbol, in my opinion, has a big old M in it. So I'm going to go back to my Draw tab, do the Add Text option, and I'm going to put a big letter M in the middle of that. 2 inches might be okay. It might be large. That might be excessively large. So we'll see. 1.5. And I'm going to have that middle center justified. Yeah, that looks good. Oh, that's way too small. What was I thinking? Okay, so I'm putting my little m right in the middle. That looks cool. If I wanted to change his properties, I can click on him and go to the text properties over here on the right-hand side and make him a little bit taller. So maybe 0.3 inches is cool. Sure, that looks gorgeous. Here you can actually control all of the colors and font types and whatever you want here. So a lot of the time I like to do is I like to make my motor symbols have a pink M in it because this is my video and I can do that. Looks super cool. Okay, so now we have kind of the graphics done of the symbol. And now what we need to move on to is the circuitry of it. Okay, so this is where you go back to your edit symbol tab up at the top. This is the part that's a little bit different than something like your vanilla AutoCAD or DraftSite or something. This is where this component is matching up the circuits from the symbol, and it's like, okay, here's circuits that are represented on the page. It's then, if you have a manufacturer part applied to it, it's like, hey, these are the circuits that this manufacturer part has available to use, and it's matching those 2 things up so that the database knows which symbols have the correct circuitry to match up with those manufacturer parts. I'll probably have another video on how manufacturer parts and symbols connect together. But most of how it's doing it, is using circuit structure in both of those 2 things. Okay, so the type of symbol I was making here is a motor symbol. It's a 3-phase motor symbol with a ground. And just by saying that to myself, I'm already telling myself I have those 3 phases are 3 distinct circuits that I need to have in my symbol, and then the ground is a 4th distinct circuit. So in that case, I know I need to add circuits. So I could do it by saying, hey, I'm going to click this new circuit button a few times to do that. So I'm going to click new circuit, and it's saying like, how many circuits are we adding? And in this case, I'll say, hey, I'm adding my 3 circuits for my 3 phases. The circuit type is saying like, hey, how do you want to define those types of circuits? This piece is how the manufacturer part identifies what circuits it should line up with on the symbol. So in the scheme of things, it doesn't matter a ton, like what you actually call it, as long as you're calling it the same thing that's in your manufacturer part. So matters, but doesn't matter. A lot of students that I used to have would get like really stressed out if they were correctly defining something. And really the only stress you need to have in your life is, hey, does this match up with the manufacturer part that I made? And there's other ways that you can ensure that it always does. But in this case, I don't have a manufacturer part sitting around for it. So a lot of the time, when you select the circuit type dropdown, it's going to look in your classifications for what the most common types of circuit types your motor 3-phase uses. So in this case, motor seems like it could be a really good circuit type to select. Notice there is a ground option that we'll use later, but motor is a super good one to use if you're using something with a motor. So I'm going to have 3 circuits of the type motor, and then the information transmission is really talking about how the wires are going to behave in a to from list. So disconnectable means that none of the circuit information is passing in through the circuit and going anywhere. When you add a wire, whether you're defining it with a wire number or an equal potential number, it's really going to stop at this connection point. So, I mean, there's a lot that goes into that information, but most of your schematic symbols typically can be disconnectable. Passing circuit types are something that you might see in a terminal where you're like, hey, the piece of wire ends here, but the equipotential name I want to pass through to the other side of the terminal. And then hyperpassing and hyperpassing used to scare the bejesus out of me. But really, it's talking about you can use these when you're using special symbols like origin destinations or if you're using buses. So that'll be something a little bit later, but it's not used quite as often. Most of the time when I'm making your standard symbol, disconnectable is fine. Okay, I'm going to hit OK. You can see now over here on the left-hand side in the symbol structure, I have 3 circuits in there. At this point, I know I need my 3 phases and I need a ground. So I'm just going to click New Circuit again. And I'm going to only insert 1 because I only need 1 ground circuit. I'm changing the circuit type to ground and hitting OK. If you've maybe messed up or something, if you need to change something about that circuit, you can pre-select it over here on the left-hand side. And you can see there's circuit properties on the right-hand side. So if you needed to switch the circuit type or the information transmission type, you could do that. Okay, so this is one way that we've inserted circuit types. Another way you could do it is you can do multiple connection points. And this is something I'll do more often when I already have a manufacturer part made before I made the symbol. What you can do is you can insert multiple types of circuits. So if I'm saying like, hey, I want to have motor circuits come in, I want to have 3 of them, I want them to have 1 terminal each, I want them to be disconnectable. You can line that up and then you can click add and you can say, hey, I want to have a ground circuit that has 1 of those circuits and 1 terminal that's also disconnectable. That's a way to do it. That might be with something a little bit larger, or if you have a manufacturer part before you have a symbol. Definitely, if you have a manufacturer part before you have a symbol, look into this button. It is super cool. It'll be another video for me to make to kind of show what you can do with that and how symbols and manufacturer parts interact with each other. At this point, I'm just going to hit cancel, and we're back to here. So I like to show different ways you can do stuff when you're creating new symbols in SOLIDWORKS Electrical. I hope it doesn't confuse people. I just like to have options myself and like to show options. Okay, so where we're at this point is we have 4 circuits and we need to show on the page where the wires are connecting onto the symbol. So in this case, we have 4 connection points we need to put on here. We need to have a connection point for each circuit that we have so that each one of the phases and the ground can connect to the symbol. What I like to do is when I have these circuits already set up here in the symbol structure, I like to right click, say new connection point, and I typically like to use undefined. And the reason I like to use undefined connection points is I typically don't like to dictate if wires are coming and going out of my symbol. It might be because maybe I'm not sophisticated enough to preset that stuff all up in my head. And I like to have the flexibility of using connection points that can come in or can go out of my symbol. So I'm going to use undefined. Okay, so when you select that you want to insert a connection point, it's going to say, hey, specify where on the symbol you want that to be. You can see there's like this little gray balloon next to my cursor, and I'm over here like pointing on my screen like you can see that. But on my cursor, just to the right of the cursor, you can see this little gray balloon. What that gray balloon means is that's where the software thinks the wire is coming from. So in this case, if I put this connection point onto my motor symbol like that, it would expect the wires to be being drawn from the right coming into the left, which would not be correct. I want to rotate this thing around 180 degrees. So I hit my space bar twice to rotate. It also appears that right click rotates. I'm just a space bar type of person. So at this point, you can see if I left clicked where my cursor is currently, then it would expect the wires to be drawn in from the left over to the right, which would be what I would expect would be happening. So I'm going to left click to place that connection point. Notice it has information that came in with it. This p tag 0, that's it's an attribute that automatically comes in with the connection point. That's saying, hey, when this thing has a terminal mark, it's going to show up in this location. The other information that came in next to the gray balloon of the wire is it's having the circuit number plus the connection number. So each circuit's going to have a number of its own, and then it's going to have a number of how many connection points are in each circuit. And since we are electrical people, things start counting at 0, it's why that's shown the way it is. Okay, so we have one phase done. I'm going to do the same process for the next one. So I'm right-clicking, new connection point, undefined. Notice it keeps the orientation of my balloon the same way that it was on the last time, which is good. Notice here it's saying like, hey, this is the second circuit and this is the second connection point. That's cool. And I did it again, and I'm going to do it for the ground. Ta-da. Cool. So at this point, we have our connection points defined. We have our graphics defined. We just barely have some attributes on the page. So attributes are important because they graphically or maybe textually show the information about the symbol from the database on the page itself. You'll notice we have these hashtags in front of these attributes. Anytime you see a hashtag while you're in a edit symbol interface, you can pretty much be sure that that is an attribute. It's pointing to information that lives in the database. So for example, if I select this p tag attribute, you can see that it has a description of the mark. Sometimes the descriptions aren't as descriptive as I would like, but after being in this software for a little bit, anything that has like this p underscore tag underscore some number, that's going to be a terminal mark. So from the manufacturer, you're typically saying like, hey, what are these terminals called? So that it can match up to their data sheets, and so it can match up to potentially some information that's written on the component itself. So a lot of the time this is defined by the manufacturer. There's an attribute that can show that on the symbol. You'll see when I have an example of this, like kind of how that looks. But what we need to do now is we need to put some attributes for what the name of the component is, potentially what the manufacturer of the component is, maybe the part number. That might be something you're interested in seeing. So to insert attributes, you go up to the Insert Attribute button here at the top on our Edit Symbol tab. And what that gives me is a list of all of the attributes that are available to me to insert for this symbol. So most of the time I'll put in your component mark. The component mark is usually important. There are two attributes in here called short tag and tag. Depending on the naming convention of your components in your project, there might be a slight difference. Sometimes it puts the parent component or the location in front of it. It really kind of depends on how you set it up. In my case, the tag and the short tag are going to be the same. They should say like motor number 1 on both of them. I'm just going to select the ones that I need in this case. I think it'll be a good idea for me to go through and define what all these attributes are, because that'll be really thrilling for everybody. I'm going to go down to this ref and this ref man area. What that means is the ref man is the manufacturer of the part that you're going to apply to it. The ref is like what's the manufacturer's part number of the part that you're going to apply to this symbol. That seems cool. There's a bunch of options on here. You certainly don't have to insert them all. One thing to note is under the descriptive data area, we have manufacturer data. And that's useful for things like if you want to show the power or the speed of this particular motor or your degree of protection, amongst other things. That's useful to show sometimes. It really depends on your preference of how you like your symbols to look on your sheet and your drawing standards. I'm going to click OK because that seems good to me for now. You can see over here on the left-hand side, now we have like your attribute properties. So here you can see they're all lined up. They're kind of center justified. And then if I go over here, you can say that it is middle center justified. If I select that, I can say, hey, I want this left justified. And you can see for an example that it's left justified like I told it to. You can change the text of all the height. So if I want to say like, hey, all of this stuff is in the 1/8 of an inch high, I can do that. I can make the spacing a little bit further. Maybe I want everything 1/4 inch apart. Yeah, that looks cool. There's lots of options over here. Notice it's changing everything in my selection. Some people like to have different attributes, have different text properties. You can either insert those one by one, or you can go back and change the properties later on. I think this looks great. I'm going to left click and place these. Super cool. Okay. At this point, this is a pretty good symbol. It's a good starting point. I will usually make sure that I save it. So notice that we have our, what I call the millennial save button. There's a bit of an inside joke on that, but this is the SOLIDWORKS Electrical's icon for the save button instead of your typical floppy disk. Notice that the Windows command of Control S still works, but you need to make sure to save this symbol before you try to insert it anywhere, because if you don't save it, the database doesn't know it exists, and then it won't let you insert it, and then you have like a mild stressful situation being like, I just spent all that time on the symbol and it's not even in here. You just need to save it. And if you make any changes to a symbol and want them to show, you need to save it again. So I'm going to go back to my project. So if you're in a symbol editing document and you don't have another sheet open, you can always go over to the Documents panel way over here on the left-hand side, and then you can look at any documents you have available in a project. Usually I'll have some kind of sandbox project that I will test my symbols out in a controlled environment to make sure that they are working the way that I expect them to be working. So I have a project open. You don't necessarily have to have a project in order to create a symbol. I just like to do that to test it out. So I'm going to open up a schematic sheet because I made a schematic symbol and they only really work on schematic sheets. And then I'm going to go up to the schematic tab at the top and try out my new symbol. So I'm going to do insert symbol. It remembers the last symbol I tried to insert when I was designing something. Apparently it was that, and that's not what I want anymore. So I'm going to click this other symbol button. Here I could either use the classifications tab to browse for whatever symbol I'm looking for, or I can use the filters tab and specifically look for something. If you do use this filters tab, make sure to remove all of your filters first. If you don't, then you'll give yourself some stress thinking that your symbol doesn't exist when really you have some filter preventing you from seeing it. In this case, I'm just going to type in example because I knew that's what I named it. You can see he lives in there now. And I'm going to double click him. And you can see that he's trying to be inserted into my drawing. So you can either click the little bubble icons to change the orientation of the symbol. You can use spacebar if you want to. But I kind of like how it's oriented initially. So I'm going to left click to place him in there. Do notice that my cursor is right at that insertion point that was specified in the symbol. Heck yeah. All right. So when I do that, also I have this ask for properties box selected, which I like. What it does is when I put that symbol on the page, it asks me to define the properties of that symbol as I go. And I prefer that because I'm sure I will forget to go back and change those properties, and then someone's going to yell at me. So I'm asking for the properties. Notice it's already calling himself motor 1, and that's because that mark group was defined in the symbol itself. Here is if you wanted to give it description or to whatever other symbol type things that you want to do to it. At this point, I'm just going to click OK and see how this thing looks. And it's pretty sweet. So you can see that I have those connection dots where I expected them to be. I have the name coming through on that tag attribute. I'm going to go back to my example symbol. So you can see that tag attribute's filled out. Notice that the other attributes are not filled out. That's because I haven't defined any of them. I haven't selected a manufacturer part, which means those two will not show up because I don't know who's making this motor or what that part number is. And these terminal marks are also not showing up because this information gets filled out in the manufacturer part. So all of that information isn't showing because it's not defined, which is good. All right, so the other things I like to test out is I like to draw up some wires to make sure that the trimming functionality of my connection points is working well. So I'll draw some single wire. I personally don't care what type of wire, I just need some wire. I'm going to draw one wire at a time so I don't confuse myself. And what I'll do is I will left click and draw a wire. And a lot of the time I will overshoot the wire to make sure that when I complete the wire command, the trimming function is working. One, I'm making sure of that because I am too lazy to trim my own wires. And two, if the wires don't trim, and I think they should, that also means the database doesn't think those wires are connecting. So you'll see me overshooting a lot of my wires like this. And so I'll just draw a wire a little bit too far, then draw another wire a little bit too far. And the fourth wire. Okay, so now I'm going to right click to close out of this command. You could hit the red X button if you wanted to. All right, so those wires did trim. That means that I, in my symbol, have my snap settings done correctly. And in my schematic page, I also have my snaps on, which means that everything's snapping to where it should be snapping, and the database is assuming those wires are connected to the terminal points that they're drawn on. I'm going to leave that where it is tonight. 1, because I am tired. 2, I think it would be good to create a manufacturer part and show how this works with my custom symbol. So create a custom manufacturer part and show how the interaction works with my symbol. That's where I'm going to leave it. Thanks for watching, and hopefully this was helpful.